So before starting, if you have any question from the last last tutorial session, you can ask me. Okay. Yeah. So I think my screen is visible to all of you. Yeah. So this is tutorial for week 3. This is Rahuldev Ghorai from ISA Tiruvananthapuram. I'm a PhD scholar there. So uh, this is for my PMRF fellowship, the partial requirement for my PMRF fellowship. I am teaching, and this is my third lecture, maybe third tutorial session. So let's move to the topic on which we will be discussing the questions, and we'll be doing some the questions answers also on these 3 topics mainly: derivative and differentiability uh, for one variable function, and then we'll move to the 2 variable functions, and then the composite for the composite and homogeneous functions. Okay. Yeah. So mainly we have done in the previous class the continuity of the 2 variable functions. How to do? We show that for different path, if you go through different path, the continuity, if the value are different, then you don't get the continuity, and it will be discontinuous. So a function at a point, if you have a function f, sorry, just Okay, so function is there. So if you have a function f, so let's say the value it is taking xy, where xy's are real numbers. So you want to, let's say, want to check at x naught y naught whether this function is continuous or not. So you approach through, limit, we write x naught y naught, this type of thing, and then f of xy, that should be f of x naught y naught. Now to check the limit this xy converging to this x naught y naught, that can be through different paths, and if you see the different path, it is you are getting different limit, then the limit won't exist, and then we cannot say the continuity at that point. So what I am telling, the limit does not exist, that implies not continuous, that you can show, and limit does not exist, that you can show using different path also. Like we have shown that this for let's say x over square root of x square plus y square, this if you choose y equal to mx path, let's say we want to find limit at 0 0, so you choose y equal to mx, sorry, not y equal to mx, yeah, sorry, y equal to mx is fine. So take y equal to mx line and you go through that line, and you will see the limit will be, as x tends to 0, y tends to 0, limit will be x over x times root over 1 plus m square, as limit x tends to 0, that will be 1 over square root of 1 plus m square, that will depend on m. So changing the straight line will give you different limits. So it is not limit does not exist at 0 0. For at 0 0 point, limit does not exist, limit does not exist, so that is imply it is not continuous. So that is, limit does not exist is a necessary condition for the continuity. Now for the differentiability, there are similar, of course it has to be continuous, otherwise if it's not continuous, then not differentiable. Okay, so there are, like, the previous tutorial session will be also useful for this session, because the continuity, not continuity imply not differentiability. Okay, so one function, if you see that it's not continuous, then you say it is not differentiable. So but the other you cannot tell. So this we will go to, now we'll go to the differentiability definition, the formal definition. Take it as a formal definition. The function is differentiable at x naught, is in one variable, it's x naught, if the ratio, this ratio tends to a finite limit L, as del x converges to 0, del x becomes very small. So at least if you remember this thing, you can you can do the question, all the questions, if it's for one variable, and it's a formal definition you will be telling. And this L, if it is a finite limit L, then that limit will denote by f prime x naught, because at x naught we are finding this difference. Okay, f of x naught plus del x minus f of x naught over del x. So the geometrical interpretation, already I think Professor Jitendra Kumar, he already discussed all these things. If you have any other further questions, you can ask me, or you can ask in the discussion forum also, I think. So those you can do, but here at least you remember this thing for the question answers, solving the questions. Okay, so this is yeah, so as I said, the continuity, differentiability, you can prove that differentiability imply continuity, but the converse is not true. And what does this imply? Differentiability imply continuity, imply not continuity, imply not differentiability. So these are some logical not differentiability. So okay, and the differentiability imply continuity, but converse is not true. That example is fx equal to modulus of x. So how you show that if fx equal to modulus x is not differentiable? So here answer is there. So I'll start here maybe. So you see fx equal to modulus of x is not differentiable, because Let's write what is modulus of x. How it looks like? Modulus x looks like x when x is less than equal to 0, negative of x when x is, sorry, I wrote, I made mistake. So greater than equal to 0, and when x is less than equal to 0, it is minus x, right? So the graph of this, it look like this and this. I mean, you take one, suppose 0 point, so you will get image 1 1, right? Here you take -1 0 point, you will see -1 1. I mean, and we see there is a corner. I mean, here the corner is forming. It's like if you zoom it, the corner will be like this. So this function will be continuous. In this, like this situation, the function also you can show that this function is continuous, right? As x tends to 0 from both sides, you will see the limit is 0 as limit x tends to 0, and the function value also 0 at 0, right? So it is continuous. The modulus of x function is a continuous function. But because of this corner kind of thing, you will see it is not differentiable. How is that? I mean, so if you first, let's not go to the solution. Geometrically, how you see the graph is like this, right? So now you start with tangent from here. Suppose, let's say here the tangent will be this line. Same. Let's draw with a different color, maybe. Yeah. So let's say at this point. So mainly for the differentiability, you start with the, like, you have to calculate differentiability at this point. You start with this point, you come approach to here, and you come approach to here. That's what you are doing, right? This is from x plus del x to x you are going. So you, whatever point you take, the tangent will be up. When x is greater than 0, tangent will be this only, right? Whatever point you take, and when you approach through this direction, so that will be the tangent line will be this. These are tangent line. Don't get confused between the tangent line and the graph. The graph was the blue line. Okay, so you can never get same limit. I mean, that ratio, when you take the ratio and you take right hand limit and left hand limit, they are different. So the limit of like x tends to 0, I mean, we say del x tends to 0, the limit, that definition f of, here we need to check at 0. So 0 plus del x minus f of 0 over del x, right? You have to check this limit. So once you need to check this limit, so to exist this limit, at least the del x tends to 0 plus and del x tends to 0 minus, they should be equal, but here that is not happening. So that will show it here. So any doubt in this geometrical interpretation? Everything okay? Okay, yeah. Satya Prakash said no doubt. Okay, so you see, then that's what we are doing here. Now you now know the geometrical interpretation. You will see that's why slope, whatever you are getting, 1 and -1. So for this line it will be -1. For this line it will be always 1. So you don't get the same limit. So limit of this quantity does not exist. So you cannot talk about differentiability. So limit has to exist and it has to be finite. So you take limit s to 0 plus, anyway we are writing this del x as h. Okay, that does not matter, it's a dummy variable. You can take h, which is like tending to 0, any number, any like a sequence of number. Then this quantity is limit h tends to 0 plus f of h will be h. That's what the definition is here. It's a definition here. So h minus 0 over h, and since h is not equal to 0, you can h over h, that will be 1, because as like I said in the first class itself, I think when you take h tends to 0 plus, you don't need to necessarily take h equal to 0. Okay, that case you can assume that is always. So when you take this, the limit will be 1. But when you take for this case, the when limit h tends to 0 minus, I mean h is less than 0. H tends to 0 minus imply mainly, so h has to be then less than 0 and h is converging to 0. That h tends to 0 minus imply this. And h tends to 0 plus imply h is greater than 0 and h is converging to 0. That thing. So when h is less than 0, the f of h will be minus of h. That's what it is written. And then when you cancel it, it will be minus 1, whereas it was here 1. So you are getting different limit for the different direction. So limit actually does not exist. The concept of limit is same, but here the ratio, the limit of the ratio you have to calculate, that ratio is different. For the continuity, you had only this quantity, the first quantity, right? Means the upper part. But for the differentiability, you have some 1h extra, the ratio you have. In the continuity, we did not add ratio. Okay. So we'll now, any question up to here? Then we'll move to this. I think it is you understood. If not, you ask me. Otherwise, we will move to the next, mainly the differentiability for two variable functions. That's why I'm telling. If you have any doubt in the one variable, you tell me. The function of one variable. I showed an example where the function is not differentiable but continuous. It is continuous. Okay, but differentiability will give you continuity. That is theorem is there. Okay, and not continuity imply not differentiable. So these three things you have to remember, or you have to understand. Any questions up to here? I will stop for some time, maybe just for a few seconds. I will stop. I mean, if you have any question, you tell me in the chat box, or you can unmute yourself. It's better if you unmute yourself and ask me if you have any doubt. Okay, so if so, without delaying, I will proceed to the next part of the lecture. I mean, the second part mainly you can think as the second part, and this is the mainly. So if you have the function f is from R2 to R, and f is differentiable at one point x naught y naught, then the derivative will be given by this del f del x. This is a notation. So you know this is a gradient, right? And the gradient in the two variable, if f is a function from R2 to R, it will be like this: del f del x and del f del y. And we all of us know this, what is del f del x and del f del y at some point, right? Because we did in the last class, I think we did this del f del x and del f del y. So for your sake of understanding, I will be writing maybe x naught y naught for one at least. This will be limit as h tends to 0 f of x naught plus h y naught minus f of x naught y naught over h. So this limit is the del f del x, and del f del y will be x naught plus y naught plus k minus f of x naught y naught over k. Okay. So that was the del f del x, del f del y. So if the function is differentiable, so read this para properly. If the function is differentiable, then you can write the derivative of a function like this. Okay. If the function is differentiable, so when the function is differentiable, that is not this condition, right? If the function is differentiable, then the gradient will be like this. But when the function is differentiable, you forget maybe this part. Forget this part. So when the ratio, this ratio, f of x naught plus h, y naught plus k minus f of x naught y naught minus this gradient f at x naught y naught dot h k over the norm of mainly this one implies this one equal to h square plus k square. Okay, don't get confusion. So this ratio will converge to 0 because you had in one variable you had one ratio, that ratio was in one direction. So here you have two direction mainly, so you have to consider one more thing. So the thing anyway that you remember, or you just try to do some practice question on this, then it will be fine. So what I'm telling is, f is differentiable at x0 y0 if the ratio converges to 0 as h square plus k square converging to 0. I mean the hk are converging to 0. When the hk converges to 0, this will be differentiable. So now one basic question is, if it is not even differentiable, can we write the gradient of f? So people usually think that gradient of f you cannot write if it is not differentiable. But if even though it is not differentiable, if fx, the partial derivatives exist, then also you can write the gradient f function, right? This gradient f function, this one. So this function, if del f del x and del f del y exist, then you can write gradient f at that point, even though it is not differentiable. That will come that fx fy both exist for a function of two variables, both exist. Even then the f is not differentiable. F is not differentiable. So this example will be there. I mean, it's not always. The example will be there. The fx fy both exist, but f is not differentiable. Example is there. We'll do later. So try to understand here. So the thing is, if the function, even though it is not differentiable, you can write the gradient at that point, because the gradient is nothing but the partial derivatives. And when we talk about derivative, the ratio, this ratio will come into the picture. That you have to check that whether this ratio converges to 0. Otherwise, partial derivative may exist, and then if that exists, then you can say that the gradient of the function is the del f del x and del f del y at those points. Okay. So this theory a little bit clear, because I'm telling all these things because I will need all these things to solve the questions, all the questions. This is very important. So you have to do these things. So mainly, how we can write this quantity as, this ratio as f of x0 plus h y0 plus k. Suppose you are gonna check at x0 y0, the whether function is differentiable. So mainly, if what you can write, it is nothing but h times f of x add x0 y0 minus k times f of y x0 y0 over h square plus k square, square root of this, whether this quantity converts to 0 0 as hk converts to 0 0. So you need to check this. If that happen, then sorry, I made a mistake here. This will be 0, right? This is a one variable thing. So this is 0 as hk tends to 0 0. If this happen, then the function will be differentiable at x0 y0. So here I do this like the necessary condition for the differentiability is continuity and the existence of partial derivatives. So if the partial derivatives partial derivatives, see, I mean all the derivatives, two derivatives for the two variable function fx and fy. So if it is continuous and the partial derivative both exist, then you cannot say that that function is differentiable. These are necessary conditions. So what is the meaning of this necessary condition? So if one of this continuity or the one of the partial derivative does not exist, that will imply that function is not differentiable. You understand? So not continuity, like not continuity imply not differentiability, or not existence of at least one partial derivative. that implies also not differentiability. So you start finding the partial derivatives. If one of them does not exist, then you say that it's not differentiable. It will be very easy. So because to calculate the difference, the ratio conversing to 0, you need to show that you need this fx fy value, like I said, like it is here already. So fx and fy is needed to calculate this ratio. So we have to find out the ratio first. And if we see the ratio does not exist, the limit fx and fy that does not exist, then we will say that it is not differentiable. That will become very easy. So necessary condition implies that. But the differentiability, the continuity and the existence of two partial derivatives does not imply differentiability. That we will see. And the second line is the sufficient condition for the now. The sufficient condition. It is sufficient. I mean, if we saw that the continuity of one partial derivative and the existence of the another partial derivative, then the function will be differentiable. Okay, this will imply differentiable, but then the necessary condition that does not imply differentiability. That if that does not happen, then it is not differentiable. Okay, these are two difference between your necessary and sufficient condition people use in maths. Okay, so necessary condition if you use to prove not differentiability, sufficient condition you use to show differentiability. Okay, so that's what they are written here, that even existence of two partial derivatives does not imply differentiability. That we will see later. We'll see with the example. So that this okay, so that this function is not differentiable at the point 0, 0. So is the first question. Our first question. We'll see that the function is not differentiable. Okay. So now first to show the differentiability, mainly we have to first find out fx. I will start here mainly the above to the above. So fx at 0, 0. We have to find this quantity to so the ratio, that ratio, differentiability ratio, right? So we'll start with this limit as h tends to 0, f of 0 plus h, which is h comma 0 minus f of 0, 0 over h. That will be equal to, at 0, 0 function is limit h tends to 0. F of what is f of h0? Anyone? F of h0 is 0, right? Okay, okay, good. H0 and f of 0, 0 is 0, so this will be then 0. All of you understood? So because h is not equal to 0, h is conversing to 0, we can assume that h is not equal to 0. 0 over h will be 0. So whatever the h tends limit h tends to 0, that will be 0. Similarly, I think you understand that fy at 0, 0, that will be also 0. Similar, exactly. Who said? I will check the message only. Yeah, Ananya, yeah. So this will be also 0. Good. Okay. So then fy0, fx0. Now we will try to find out that our main thing. Now we can proceed to the main ratio. What is that? F of 0 plus h, which is h, 0 plus k, which is k, minus f of 0, 0 minus h times f x at 0, 0. Let me write, otherwise like it will be easy for you to follow. Fy at 0, 0 over square root of h square plus k square, right? So you see this fx00 is 0, fy00 is 0. So what you can further write, this quantity 0, 0 f of hk minus f of 0, 0 is also 0, and this quantity also h times 0 minus k times 0 over square root of h square plus k square. So total what we get at the end, what we get, hk tends to 0, 0 square root of hk modulus over square root of square, okay, square. So you see, it becomes a simple finding out a limit. We have already done all this type of limit, how to proceed with. So we'll see whether limit exists. So observe that this fx of your fi, the partial derivatives, all partial derivative exist. But the question is given that is not differentiable. So that we will prove that partial derivative. So if we can prove this is not differentiable, then we can show that this is not differentiable although partial derivative exists. All the partial derivative at 0, 0 exist. That we have proved exist and is equal to 0. So now please tell me, anyone of you, anyone can tell me that, can anyone tell me that whether this limit exists? We have done this type of questions. So if not, how to show that it is not exist? See, even though this limit exists, it has to be equal to 0. Please remember that also, okay? The ratio, this ratio has to be 0, not anything else. Even though exist, if does not exist, then gone. I mean, then also it's not defensible. But even though it exists, if it is something else, some other limit it is, then also it is not defensible. Okay. So I'll show that this quantity. See, it has to be 0. The limit has to be 0. Okay. This limit ratio has to be 0. Okay. So now tell me whether this ratio is 0. Here our case, this ratio, whether this is 0, this limit is 0, or it exists. It's not defensible. The question is asked is not defensible. So it may happen that this limit exists and is equal to a finite number, or it does not exist. The limit does not exist. That two things can happen.
So we can take h is equal to mk or k is equal to mh, and then we will see that the limit depends on m, so it does not exist.
Okay. So any other way? I mean, this is a very good answer, and of course, this is fully correct. Any other way to do? Good. Who told? Anyway, I did not see, but I did not see you. Yeah, it's a correct answer. Okay, you choose the path like h equal to mk, then you will see the limit will be this limit. Then will be, I will be writing like h equal to mk path. Then when you take h equal to mk path, this limit if exists, then it should be equal to, as k tends to 0 only, because h tends to 0 implies k tends to 0 also, or k tends to 0 implies h tends to 0 also. Then it will imply
the limit does not exist.
Exactly. If exist, that's why I'm telling you. That's why I took the path like this, h equal to mk path. And my equal sign are now in the different color also. You see, okay. So try to interpret like this. It does not exist, of course. So that's what we are showing. We are going to show that the limit, if exists, that will be equal to. I'm assuming if exist, it will be equal to, through h equal to mk path, it will be modulus of m over square root of 1 plus m square, mainly m square plus 1, this is equal to m square. So that is nothing but modulus of m over square root of 1 plus m square. So through different path you are getting different limits, so limit does not exist. So you can say that the limit does not exist. So while writing in the exam, if it is like question for 2-3 marks, so instead of writing equality here, equal to h equal to mk path, you write in the language just through h equal to mk path, this limit of this function is like this. So it is different for different paths, so the limit does not exist. Okay. Any question here? I'm doing understanding. Okay, right? So the limit does not exist. So that implies the function is not differentiable at the point 0, 0. So the function which has all the partial derivative at origin 0, 0 point, but the function is not differentiable at the point. So this, for this function, you can write the gradient of this function at 0, 0 is equal to vector valued function. The gradient is a vector, it's a field kind of, right? So this way two variables. So that is 0, 0. Gradient f still exists. You can write gradient f here, but the function is not defensible. Okay, the defensibility is much more stronger in the sense. If you have any doubt here, ask me. Otherwise, I'll see. This is the solution. I like is you can do it. Like we did already. Yeah. Now we'll move to third question. Okay. Please try to do this question and let me like know whether this is defensible. This question might be wrong also. Okay. Might be defensible or might not be defensible. So I'm giving you a hint that please tell me what is f of x at 0, 0 and fy at 0, 0. Okay. Take maybe 2-3 minutes. I think it is better if you try. Okay. So try and please tell me. Then we will do. Again, we will do also. But you try. Yeah. Any answer here? Okay. So both are 0, 0. So anyone else got who? Like only one person. I see.
Yes, sir. I have also got.
You also got Satya. Okay.
Yes, sir.
Okay. Okay. So fx and so I'm assuming then, right? But I think it is very easy because f of, I think by observing these things you wrote, right? Fh at 0 for any h not equal to 0, right? Or f of 0k, they are also 0, and f of 0 is equal to 0, 0, they are also 0. So that's so easy to say, check that this the partial derivatives exist and that those are equal to 0. And in this case, partial derivative exists, also the function will be defensible, that we'll see. So you try to then find out the limit like that we did. So that you have you checked that limit hk tends to 0, 0. The partial derivatives were 0, f at 0, 0 is 0. So what will happen? The ratio will be, sorry, not xy, hk times h square minus k square over h square plus k square. There is a function value over this h square plus k square, right? Square root of h square plus k square. So now how so you saw that this limit exists? So this is equal to limit as h k tends to 0, 0. Yeah, tell how you saw that. Yeah, so hk times h square minus k square, what you can write, right? So h square plus k square times square root of h square plus k square, right? So now what you see, this h square minus k square over h square plus k square, this quantity one can write as less than equal to 1, that you can show that, right? So how you prove that? Did you prove that this is a differentiable? How to show that this limit is equal to 0? Yes?
Doing,
Unmute
sir.
yourself and tell me, please, if you know this thing. Okay. The answer is there. Answer is I can just do it now. But can anyone tell me?
Sir, doing, sir.
Okay. Take time. No problem. Thank you for informing. Okay. This is good, right? You can try here itself, and you can sorry. You can try here itself, and you can check that whether it's you are doing correctly. I am here to assist you also.
Sir, it is differentiable.
When what is the limit you are getting?
Sir,
This Satya Prakash, right? You are?
yes, sir. Yes, sir.
Okay. Anyway, what is the limit?
Sir, yes, sir. Sir, it mk square m minus 1 uh, by m plus 1 into root m plus 1.
So you take what?
Sir, I have
Why do
taken
you?
h is equals to mk.
Okay, h equal to mk path. Are you getting different limit?
No, sir, it is 0 when limit k tends
But
to
that won't give you it is the limit, total limit is 0. I told you, right? You have to maybe again take h equal to mk square path, because you can
okay.
go through different curve, right, to 0, 0. So
Okay.
why only h equal to mk, or
Okay.
why only k equal to mh? It can be h some h square equal to mk also, right? So
Okay.
to show the limit of this function,
Okay.
you should not go through all this path. So if you are thinking that limit does not exist, then you go through that path. Now what you can do, your next step will be, you saw that
So
through h
can
equal
we
to m.
take r h is equal to r cos theta and k is equal to r sin theta?
Yeah, that you do. That is good. That is good way to show if limit exists, the limit. Okay. See, whatever Satya is doing, that is also correct. That from that you can understand that what will be the limit. at rest, right? If through h equal to mk path, what he is telling, it is 0. That observation he got. Now you can try to think that you can take some other path also, Satya. Okay, if you
Yes, sir.
take
But
another path, then also you will see the limit will be 0. Then you confirm that limit, kind of confirm that limit is equal to 0, and then you have to prove for general one. You don't need to, no need to take exact like some typical path. Okay, that you should not take. For that, from the path, what you know, that limit exists, and a limit might exist, and if it is exist, it will be equal to 0. Now you try to show that the limit is equal to 0, like Ananya told, right? Was that Ananya, like someone who told
Yes,
to?
sir. It was me only.
Okay. So that's what. So you go through her process. Now I have not like the h equal to, you take r cos theta.
yes, sir.
Okay, k equal to r sin theta. So if we take that path also, I'll tell another route also how to show that the limit. So if you take this, will imply limit as r tends to 0, only r tends to 0 is enough, right? In the when you change the Cartesian coordinate to polar coordinate, only hk tends to 0, 0 imply r tends to 0, or r tends to 0 imply hk tends to 0, 0, 0, right? So then what will happen, r square, we'll see whether it is like we are getting this sin theta cos theta times so r square cos square theta minus r square sin square theta. So that will be r square cos 2 theta, right? Correct? Over r square times square root of r square. Is it correct? So calculation is correct, right? So then limit as h tends to 0. Please confirm that whether the calculation is right. Then r time you can write sin theta cos theta cos 2 theta. See, whatever the theta functions here, they are bounded. So limit as r tends to 0 will give you 0. Limit as sorry, not h tends to 0. Here r tends to 0. Okay, please. Sorry for the thing. Yeah, r tends to 0. Limit as r tends to 0. R sin theta cos 2 0. That is equal to, that will be 0, because the whatever theta you take, independent of theta, r is there. So independent of theta, this quantity is bounded, and when r tends to 0, you see this thing will give you 0. So limit exists and equal to 0. Here we did not, to show the existence of the limit, we did not take any path. We did in a general way, because any Cartesian coordinate you can change to polar coordinate. So that is general case you did. So also we can do in this way, like we did. So like I said, h square minus k square over h square plus k square, h square minus k square over h square plus k square, that is less than 1, you can show, right? Think it. If that is so, then from here, what you get, this quantity you will get. And then we did again. So for this function, we know it is converging to 0, 0, we have proved, because this hk will be less than equal to h square plus square root of h square plus k square, right? So then you can show like that also. So two process, those are fine. We did two processes, so both are fine, right? So h square minus k square over h square plus k square, that is less than equal to 1. Then, and also we can show that this hk over, where to write, so like hk over square root of h square plus k square, this both hk, I said both hk, modulus of hk, or that will be modulus of h time modulus of k over square root of h square plus k square, and both h or k is less than equal to square root of h square plus k square, and then you will see this type of thing. Half also you can get, or you can get square root of h square plus k square, and that tends to 0, 0 as hk tends to 0. So in general you can show that the limit is 0. The ratio of this quantity is 0, hence that implies it is differentiable. This way also like this way, the from polar coordinate to Cartesian coordinate. Okay. So if you have any doubt up to here, please ask me. Otherwise, I'll move to the next question. I'll just wait for. So yeah, tell.
Sir, I have doubt in that h square plus k square by 2 root that step. I couldn't understand how is.
Sorry.
Sir, in this solution,
Yes.
hk modulus by root h square plus k square is less than this step. I couldn't understand.
Okay, so let's do it anyway. So that it is 2 is there. I'll do in 2 way. Okay, that also you can prove. I think you can prove this one also. So this one, even though it's 2 is not there, if I don't take 2 also, it will work. So this will be less than equal to h times k over square root of h square plus k square, right? That implies, because both h and k, h also less than equal to square root of h square plus k square, and modulus of k is less than equal to h square plus k square. So that will imply this quantity is less than equal to h square plus k square. So when you take limit both side, limit as hk tends to 0 0, hk over square root of h square plus k square, that will be less than equal to 0, and this quantity is always 0. I mean, this will be then equal to 0, equal to limit hk tends to 0 0, square root of h square plus k square, means that is equal to 0. This equal to you can write because this is a positive function, so you can write. So now what he is asking, how that half came. Okay, so also what you can write, this modulus of h and modulus of k, it is nothing but less than equal to modulus of h times modulus of k. Now what we will see, this h square plus k square minus 2 times h times k, that is greater than 0. Why? I'll write that is equal to modulus of h plus modulus of k, that whole square, that is greater than equal to 0, right? That implies 2 times modulus of h, that's modulus of k, that is less than equal to h square. Modulus of h square plus modulus of k square, that is nothing but h square plus k square, because they are real number, right? That implies modulus h modulus of k, that is less than equal to half times h square plus k square also. In different way you can write. I mean, mainly we need to prove that this limit is less than equal to 0. Now when you have hk is less than equal to half h square plus k square, from here what you can write, this also limit is nothing but hk tending to 0 0, h square plus k square over 2 times h square plus k square. That's what I wrote here, right? Now is it clear to you?
Yes, sir. No.
Yeah. Any other question? So you can estimate it, right? This is an estimation. You can estimate in your way. I did see. I wrote one thing here. I told you one thing, like another way, and another one. And I think she told another way. So we kind of did 3 type of different things. But this last 2 are not too different exactly. The estimates are different only. One has half kind, one half, but another is we don't have half. Also, it's fine. Okay. So yeah, if you have any doubt, please ask me. Otherwise, you move to the next question and so on. Okay, so let's move to the next question. Yeah, the hint is given, I think, but let's try. fx00, fy00, whether they are coming as 1 for both of, like for all of you. Oh, just quickly, please check it. I have given the hint. So fx at 0 0 and fy at 0 0, whether that exists or not. We'll see some other questions also, some other type, but this type of questions will be coming at least one question in like all type of exam, whatever exam you will give. I think this type of question will be there from if the syllabus included, this syllabus is included, then this type of question will be there. I mean, this is a basic question mainly and a very important question. So by doing this, you can you are solving mainly, you are trying to find out the partial derivative also. Also, you are finding out whether it is differentiable or not. Mainly everything is there. Okay. So this part is, you are getting this part, is it correct? Correct. Is it correct? So fx at 0 0 will be, it's like limit as h tends to 0.
It's correct.
Correct, right?
Yes, sir.
h0 minus f of 0 0 over h, which is nothing but 1. You can check it, because h0 is h cube minus 0 cube over h square plus 0 square, which is h, and h over h will be h. Similarly, fy will be also again 1 minute. What about fy? Is it correct? Other than Satya, what is fy at 0 0?
So it's -1.
Exactly, it's not 1, right? So there's a typo. It should be let's do it maybe. Limit as k tends to 0. So that's why I asked you. It might be typo. Okay. Limit k tends to 0. 0 cube minus k cube over 0 square plus k square minus 0 over k, right? That will be k cube over k cube minus k cube over plus k cube. That will be -1. Okay. So this one is 1. So I'll just correct it here itself. So this is equal to -1. Okay. Okay. So this is equal to -1. fx 0 0 1, fy 0 0 is -1. Okay. That we got. Now we will proceed to the differentiability. So you will see different type of question in the coming. The coming questions will be the next questions will be different type maybe, but now we'll do this differentiability question again. Okay. You also try to do this with me. Then you don't need to spend extra time, I think, in these things. You can just practice here itself. So what will be this the ratio? That ratio you remember, right? F of hk, because 0 plus h, 0 plus k, that is hk, minus f of 0 0 minus h times fx at 0 0 minus k times fy at 0 0 over square root of h square plus k square. What will be this limit at hk tending to 0 0? What is f of hk? Is h cube minus k cube over h square plus k square minus f of 0 0 is 0 minus h time, what is fx at 0 0? 1 minus k times, what is fy at 0 0? Is -1 over square root of h square plus k square. That will give you nothing but limit as hk tending to 0 0 h cube minus k cube minus h minus k times h square plus k square over h square plus k square times square root of h square plus k square. See, I made it, I think, little simpler, like made your life little easy. But now tell me, what will be the limit of this thing, whether it exists. If it exists, see, the question is given the limit, it is not differentiable. So either you prove that the limit is some other constant, or you show that it does not exist. One of them is enough to show to prove to give the answer to the question. Okay.
Sir, I'm getting limit does not exist.
Why? How?
Sir, by if we simplify this expression and then put h is equal to r cos theta and k is equal to r sin theta.
Okay, if you do that, then what is the limit you are getting?
Sir, I'm getting that r terms will cancel and it depends on theta.
Great. Okay, so that is the one way. Of course, that is the one way. You can prove that the limit does not exist. It depends on theta. Yeah. So that type of thing question also we did, and she did exactly correct. Like whatever she did, that's exactly correct. Also, you can take h equal to mk path. Satya, you did h equal to mk path.
Yes, sir. I'm doing.
Yeah, I'm not asking anyone else because they like only those two are responding in the class, so that's why I'm asking them. So anyone else who are here in the class, they can also try to unmute themselves, unmute, and they can also ask me. Okay, so it's not about only two I am talking about. Just if, by talking you can be more engaged in the. For me, it will be also good, and for you also it will be good. So whoever trying to talk, like in the unmute themselves and talk, then I will also talk with them. Okay, so there is nothing like only two people. So
Sir,
the
it
thing
depends
is
on M.
exactly, so it's equal to mk, then it will depend on. So I am not doing here depend on m. Mainly limit depend on m. Okay, that we'll see, and that imply limit does not exist. So this does not exist. So that imply we had to prove that this limit is equal to 0 for differentiability, but this limit you are getting is it does not exist, so the function is not differentiable, right? Yeah, so that's what I wanted to share here. And here is the another type of function. I might come later because the same type of question we are doing from long time, so we'll do some different type of question, then I will be coming to this question 5. Okay. Okay, no, let's I think do it. This last question of this type of question. Okay, then we'll go to the homogeneous function and all. Those will be also interesting. So let's do this one. So should I give some little bit time to you to try whether you are getting?
Sir.
I mean, you try yourself.
Yes, sir.
Okay, 2-3 minutes. I will be then waiting. Others see, I can do it. The answer is there. I can do it, but it won't be useful for you if you don't try. Little bit you try, and all of you whoever are here, you can ask me. Unmute yourself and you can ask me where you got stuck. Okay, that also you can discuss. And if you're done also, then you can tell me, so that I will understand that I can start again, like I can start doing discussion. Okay? So first of all, is this function is continuous? You should always keep the see, now here it is given the question is given that it is differentiable, so the function will be continuous, of course. But when it's not given, something is you have to just choose the multiple choice type of question. So you should always think about the when differentiability is given, you should think about also continuity, because the continuity, if it's not continuity, then you don't need to do all these very long calculations. So if it's not differentiable, not continuous, is no, it won't be differentiable also. Okay. So, but this function, is it continuous? What will be the limit? So if I write the limit as x y tends to 0 0 x square sine 1 by x plus y square cos 1 by y, what will be the limit of this? should that be equal to f of 0 0, then continuity, right? I mean, is it equal to 0? Is it equal to 0? This part we know, the other part we know. This question mark we don't know. This question mark, and this we don't know. Is it 0? So if you don't know, then I'll be telling this limit xy tending to 0 0 x square sine 1 by x plus y square cos 1 by y. This limit, can't you write this limit as x tends to 0 x square sine 1 by x plus limit y tends to 0, because x tends to 0, so these functions are two different, only depend on x, only depend on y, so you don't need to write x y tending to 0. In this case only you can write, so don't make mistake everywhere by doing this separation. Okay, y square sine y square cos 1 by y, and what you see, the sine 1 by x function is bounded, sine function is bounded, so x square times x square is converging to 0, and sine 1 by x, as x tends to 0 also, it is bounded. X is not equal to 0, x is tending to 0, it's bounded, so this quantity also will be 0, and this quantity will be also 0, so the limit will be 0, the function is continuous. So it does not imply it is differentiable, but it's continuous. Okay, you can check like this. So what will be fx at 0 0? What will be fy at 0 0? These are very easy to check. Try, please tell me.
Sir, 0.
Why
0.
why
0.
what is the one by one you tell? So first one tell, and then another person. Okay, what will be fx 0 0? So not what is fx 0 0. What will be this f of h0 minus f of 0 0 over h? What is this? What is that ratio you are getting?
Sir, 0.
No, just ratio. I'm not taking limit. What is the ratio? This ratio. After that only you will find out the limit. Right? I'm not taking limit.
Sir, x sine 1 by x.
Not x. H times 1 by h.
Okay, sir.
Right?
Yes.
It's different. Okay. So not fx 0 0. So now I can take limit. So this equal to limit as h tends to 0, and then I take limit that equal to limit h tends to 0. But similar idea, you can say the similar thing is h sine 1 by h is bounded and h is converging to 0. Bounded function times some function which is converging to 0, then the total limit will be 0. That's always, not for sine function, for any bounded function. Okay, in the neighborhood of 0, if it's a bounded, then it's bounded, and sine function is always bounded in the neighborhood of 0 or the neighborhood of, like, it's going to infinity, all those things. And when you are going to any beyond some large number also, it will be bounded. So similarly, f of y at 0 0 will be bounded, will be 0. So now what for the differentiability, what we have to check then? Limit at hk tending to 0 0, f of hk, which is h square sine 1 by h plus k square sine k square cos 1 by k minus f of 0 0 is 0, fy at 0 some plus h times fx at 0 0, that is 0, plus k times minus k minus h times f of x at 0 0, that is 0, minus k times f of y at 0 0, that is also 0, over h square plus k square. So now how you show that this is the limit is 0? Because you have to prove that it is differentiable. How you show that? The solution is not given. So now the question now became to find out the limit as hk tending to 0 0, h square sine 1 by h plus k square cos 1 by k over square root of h square plus k square. First, you can try to guess that what will be the limit in different path maybe, or then then you can show that the limit does not exist, or if limit you can guess that what will be the limit, right? So if you choose some path h equal to mk type of path, then what we'll see through h equal to mk path, the ratio will be like m square k square sine 1 by mk plus k square time cos 1 by k over k times square root of 1 plus m square. So that will give you k times sine 1 by mk, k over square root of 1 plus m square times sine 1 by mk plus, yeah, 1 minute. So m square times, okay, that m square times minus or plus
The k square will be common.
1 by k. So your in the denominator and numerator you have k, you just take out, I just cancel it. K square you take common, but you have another k in the numerator, right?
Yes, sir.
Yeah, that's what it is. So but this function is bounded, so but as it limit, this has to be the limit at k tends to 0, right? Because h k are converging to 0, h tends to 0 implies k tends to 0, so that imply it will be 0. So but you cannot say that limit is 0, but you can predict that limit might be 0. You have to anyway take some other path also to show that it is the limit is 0. So you will see the limit will be 0 here, because not because of the thing what we did here, this is because of this quantity. See, h square sine 1 by h plus k square cos 1 by k over square root of h square plus k square, right? So this quantity is less than equal to h square, h square sine 1 by h plus k square cos 1 by k modulus, right? That less than over square root of h square plus k square. That is less than equal to, because sine x function, cos x function, they are less than equal to 1. So then what you can write, h square time 1 plus k square time 1 over square root of h square plus k square, which is equal to square root of h square plus k square. Now if you take limit at h k tending to 0, 0, this function converges to 0. So what does that imply? So that implies this limit of, what we got, see, h square sine 1 by h plus k square cos 1 by k over square root of h square plus k square. That modulus is less than equal to square root of h square plus k square. That modulus is less than equal to h square plus k square. So that you have to get. Then h square minus h square sine 1 by h plus k square cos 1 by k over square root of h square plus k square will be less than equal to square root of h square plus k square and greater than equal to minus of h square plus k square. Now we can take limit both sides. In the three cases, we can take limit. Then this limit will be 0 is less than equal to limit hk tending to 0, 0 h square sine 1 by h plus k square cos 1 by k over square root of h square plus k square, that is less than equal to 0. That implies this limit has to be equal to 0. I told also once, a less than b and b less than equal to a will imply a equal to b only. That's what we are getting. The limit, it's telling less than equal to 0, also it is greater than equal to 0. Now only possibility can be it is equal to 0. That's why the limit is 0. And once you prove that this limit is equal to 0, yeah, so that's what we started. Limit equal to 0. So that implies the function is differentiable. So that's what we proved, that this function is differentiable. Is it okay with everyone?
Yes, sir.
Okay. Others? Okay. So if it's fine, then we'll move to the mainly the next part. It's not now defensible things. Now we will be doing. Oh, of course, the defensibility we will be using maybe, but we here in the last topic, the homogeneous function mainly. Okay. So if you have a function like f of x y, and the function, let's t belongs to a real number set, then you take tx and ty, that will be equal to some, if it is equal to some t to the power n times f of xy, then we will say that the function is homogeneous of order n. Then, so I'm just writing full maybe the definition. The if f tx ty is equal to the n, then f is a homogeneous function of order n. Okay. So why we need this? Like why this? What is the interesting thing about this function? So this function, Euler have shown some property of this type of function, like you can easily find out some derivative relation like for this type of function that I will tell later. But first try to show that whether these functions are homogeneous or not. Okay, we'll see the why the homogeneous functions has nice properties. Okay. So for for this function, if arc10, what is arc10? Arc10, it is nothing but tan inverse. I mean tan inverse function we denote by arc10. Let's write it properly. Tan inverse. Okay. Tan inverse function. But tan inverse function, if you take, so f of xy, this is f of xy is equal to tan inverse function, x square plus y square. But if you take ftx comma ty, that will be tan inverse time t square time t square x square plus t square square t square x square plus y square. But you will see you cannot write this is, you can just cannot take some t to the power n, some t to the power some m time tan inverse. This you cannot do. You will see this, the function is, you cannot write like this, right? This is a tan inverse function. It will not always come, t square will come out. Okay, this is not a linear type of functions. Linear or something like it came up with the some norm type of function, it will take t square out. Okay, but if you take g of tx comma ty, you will see that is t square times x square plus y square, which is equal to t square times g of xy. So this function is not homogeneous, whereas this function is homogeneous of order 2. Okay, so order 2 homogeneous function is mainly. Okay, so similarly you can find out the homogeneous function of order n. You can see how it will be. So if you take g of xy is equal to x to the power n plus y to the power n, then the function will be homogeneous of order n. There are another functions, some other functions also which are homogeneous of order n, like homogeneous functions are there. Is it okay? At least you know the what is homogeneous function definition, right? So then let's try to show that. I think there are questions. Okay. See the nice property of the homogeneous function I will show. This is not solution of question 6 or something. Anyways, solution of question 6 we did already. So I'll just erase this thing. Okay, this is not the solution of the question. Okay, so nice property of homogeneous function of order n, right? Why this homogeneous functions are beautiful, you will see. The Euler proved that mainly. I don't know whether I remembered, but I think it will be easy. Otherwise, I will just state. Okay, let's try first. So homogeneous function f, let's say let f be a homogeneous function, okay, of order n. So then what will happen? F, suppose f is homogeneous function and also it is, let's say it is differentiable also. I mean, I'll be assuming all those things. Then what are the property we'll see? That's what. So fx, sorry, not fx, f of tx comma ty will be t to the power n f of xy, where t belongs to real number, any real number. Okay? So now, yeah, I don't know whether I can show that. Anyway, we can show that anyway, it's this by Euler mainly. We can show that x time fx plus y time fy will be n times the function f. See how this will be very useful if you know one derivative, one fx at some point, then you can find out another the one partial derivative if you know, and the function one derivative you know, mean the function also you know, then the one bit derivative you know, then another derivative you don't need to calculate if the function is homogeneous. So you can use this property, you can use this property to show also this, okay, that x time fx plus y time fy will be nothing but n times f. Okay, so I am not now proving this thing, so it's a very easy proof, you will find in internet also. So they just do some straightforward calculations, some derivative. So but remember this thing, okay. I think I'll just maybe give some box here. So x time fx plus y time fy will be nf for this homogeneous function of order n, okay. So this property will use later in some questions, okay. Before that, let's okay, or let's do it here itself, okay. So suppose a function is, suppose this question 8 is there. We'll go to the other question later maybe. Let's do the whatever we did now. So here you see the function is given that sorry, log u is equal to, the question is this, log u is equal to x cube plus y cube over 3x plus 4y. Then you show that this thing hold, and this you see this is nothing but the kind of Euler's theorem there, but it's not exactly. So we can show using Euler theorem. So what we'll see, that x cube plus y cube over 3x plus 4y, if you take f of xy is this, then f of tx comma ty will be t cube x cube plus t cube y cube over 3tx plus 4ty. You take common, then t, and you cancel, then you will get t squared time x cube plus y cube over 3x plus 4y. What is this? Is nothing but t squared time f of xy. So this function x cube plus y cube over 3x plus 4y, this function is homogeneous. So x cube plus y cube over 3x plus 4y is a homogeneous function of order 2. That implies this is nothing but log u. Is given that log u equal to this. So log u is a homogeneous function of order 2, right? That implies by Euler's theorem on homogeneous function. So Euler's theorem on homogeneous function is, I did already this one, Euler's theorem of homogeneous function. This will imply, by that what will happen, x time del x of, see, you were using Euler's theorem on the function log u. So what will be this? Times log u of log u plus y times del y of log u. That will be equal to what? 2 times the function log u. You are still not done. Now what we will use, x time, can you write like this, del u times, I mean it's not del u, you can write as d du times, this is a chain type of rule. So to differentiate this log u, you don't have u here, so you take u, then del u del x plus y times ddu times ddu of log of u times del u del y here. That will be equal to 2 times log u, right? Now what does this imply? ddu of log u is 1 by u, so x by u times ux. Del u del x is nothing but ux. Y by u times uy is equal to 2 log u, and that implies x ux plus y ui is equal to 2u log u. That's what you needed to prove this quantity. This and this, you see, so the same. We have done. Is it okay? See, using Euler's theorem, it becomes very easy. And because the function was homogeneous. Okay. If it is okay, then we'll move to the next question. It's very easy. We will use some chain rule mainly. All of you know, I think, chain rule. So that using chain rule, we'll do this question. Okay. Any doubt in the previous question, please tell me. Otherwise, try to do this question. I'll do. So you need to find here del z del t, right? So let me write this del z del t. You need to find out.
So
what
sine 2t.
I don't know the answer. I will do and I will find out.
Okay, sir.
Anyone else got answer? Anyone else got answer? Same answer? Then I think that will be the answer. I mean, not that does not imply that will be the answer, but I think that will be the answer. But yeah, let's do it. For everyone, I will be doing just because he did it already, so we don't need to now wait more times. So let's do it. So del z del t. How we can write del z del t is nothing but, so del t of f of xy, but here f is depending on x and y, so what you can write, del f del x times del x del t. Del x del t does not mean anything, so let's, because x is depending on only t, so that's why we write del x dx dt, okay, plus del f del y. See, because you cannot take derivative directly with respect to t, because f is implicitly f is indirectly depend on t, not directly depend on t, so directly depend on x and y, so that's why I'm writing this way, and that is nothing but your chain rule. Okay, it's very easy. So that will imply, what is del f del x? Del f del x is equal to del x of 4x square plus 3y square. So when you take derivative with respect to x, the y part, y is constant, we assume, so that we can assume that we can think that y is a constant, so that's why it will be 8x. So 8x times dx dt. What is dx dt? X is sin t, so dx dt will be cos t, plus what is del f del y? 6y dot, and not dot, times dy dt will be negative of sin t, because cos t, derivative of cos t is minus sin t, right? So, is it okay? Okay, now what is x here? So we have the del z del t. When you are finding out, you should try to make it only like depending on t, because the z is directly depend on t mainly, so you need to change it to only t. So for that, 8 times, you know, also x is sin t, right? Because from here it's given, and y is cos t, so you can put that, plus 6 times cos t time minus sin t, so that implies 8 sin t cos t minus 6 sin t cos t, that implies 2 sin t cos t. I think she was correct fully, I mean, great. So that is sin 2t mainly. Okay, we can keep this one also, you can keep this one, both are correct. Yeah. Okay, so any doubt here? Also, if you have any doubt, like other question also, you can ask me here also. If you were doing some questions which you have difficulty, we can try here itself also. So if not, we will move to the next question. I think this was the answer. The final answer is 2 sin t cos t. These files are already shared with you. So can you, like, do you have access to the file I said? Have you checked the other 2 files?
Yes, sir.
Okay, okay. Those are fine, right? Or should I upload without this writing this answer and all, or with answer is fine? Okay.
So with answer is fine.
Okay, okay, okay.
Yes.
Okay. If you have any other, like other than this thing also, like not other than this thing, on this engineering mathematics 1, if you have any other doubt also, you can ask me, okay, in the forum, or I don't know where. I mean, you can personal message also, that Gmail, I have that Gmail idea, email ID I have shared with you, or in the YouTube, wherever you can ask any questions, because yeah, I mean, if you need some other assignment, I have to like give some more questions, that also you can ask me. I can I have to make then, but if you have many people request me to make some as a PDF type, that also I can make. Otherwise, these questions related to this question only I have taken from many other assignment problem from different institute and also, and then I check this type of questions are there, and I gave this type of question. That's why. So you can take any other book and you can just try, or by trying here itself also you can do a lot of, I think, doing together, that will be great, right? So yeah, this was the answer. So what I wanted to tell. So any other problem you can approach me. Okay, so that's what I meant. So we have done, I think, seven question. We haven't. Okay, I've been checking whether we have not done any question. Okay, so I think we have done 8th question also. I think we'll move to the last 2 questions. Yeah, so this one you do. I did this del J del T. This one you do, and you tell me whether you are getting or the answer as E, or what is the answer. See, there can be mistake, like we saw, like one mistake was there in the hint of the solution, because I type it, just typing typo can be typo. So yeah, please, if you have if you are doing, please let me know whether answer is E, then I will proceed. Yeah, I am not telling anything because you were trying. I hope you were trying. At least tell me what is df/dt.
Sir, I'm getting till only E. I don't understand how 1 and minus 4 came.
1 minus. You are getting answer is E, right? So yeah, that's okay. It's a typo.
Yes, sir.
See, while we doing, we just. I mean, the last lecture, whatever we have from the template we take from there. So some mistake might be there. I mean, but from there is that because of that the typo came. Okay, so I told this is the typo. Answer is E. And I also told, but I did not see this one is written. Answer is see. I have removed it also. Okay, and this file only it will be shared, so no problem. So is it E? So what is df/dt? I'll just quickly do it. Okay, you just check it whether it is coming. That is del f del x, which is 1. It's not 1, sorry. Cos y plus e to the power x sin y. It is del f del x times dx dt, which will be 2t plus del f del y, which is x sin y plus e to the power x cos y times 3t squared plus 1. Now we have to find df dt at, this is f, df dt at 1 0. What is the meaning of 1 0? Means x is equal to, means when t is equal to 0, then we will see that implies df dt at x equal to 0, x equal to 1, y equal to 0. Mainly when it gives at a 1 0, you try to find out when it is x equal to xt is equal to 1, y is equal to 0. So if you take t is equal to 0, then that will satisfy. So that implies whatever the value here, this is 2t is there, so it will be 0 plus whatever the value, this will be 1. The tt when t is equal to 0, this will be 1. So it will be nothing but minus x sin y plus e to the power x cos y, only this. So that implies, and that is at x equal to 1, y equal to 0, right? That implies minus 1 times sin 0 plus e to the power 1 times cos 0. Sin 0 is 1, cos 0 is, sorry, sin 0 is 0, cos 0 is equal to 1. So the answer will be right. Is it that's how you got?
Yes, sir.
Okay, great. So then this question also is done. Yeah, we'll move to the next and the last question only. Yeah, last question is this. I think it is little difficult than we did the last, whatever we did. It might not be difficult also. Yeah, please try it. Yeah. What are the partial derivatives?
Sir, I'm getting not defined.
Partial derivatives are not defined.
Yes.
Anyone else? I'll check it. Most probably you are correct. I will check it anyway. So does that imply it is not defensible? Does that imply?
Yes, sir.
Okay, good. So yeah, if you can show that that does not fx and fy does not exist, then one of them also does not exist, then also you are done. But let's see what is the
Yes, sir.
actual
It's not defined.
why. Sorry, this is not h0. So what is f of h0? That will be, you have to give me now the reason why this does not exist. I understand what you are telling, but why? Can you justify this limit does not exist? It might not be that much needed for you, but it's yeah, in the mathematics field is it's very much useful and it's very much interesting. How to show that this limit does not exist? You got limit as h tends to 0 sine of 1 by h, right? Why this limit does not exist?
Sir, I did using conventional approach that we know that limit of whatever limit of any say x when it tends to 0, and you have sine of x by x is equal to 1, so we can multiply and divide by 1 by h, and then 1 by h will remain, and when we apply the limit we'll get 1 by 0, so it's not defined.
Okay, let's do her approach. What can you one more time? Just sine. You know sine x by x is going to 1, right?
Yes,
Going to
sir, when x tends to 0.
limit x tends to 0. Now I will not write going to 1. It is equal to 1. Now what
Yes.
you take?
So, sir, for here also, since we need 1 by h is there, so we can multiply and divide by 1 by h.
Okay, if you multiply and divide by 1 by h or 1 by x, the same. So that is imply x tends to 0. Multiply and divide by 1 by x. So that will implies again, sine 1 by x times sine 1 by x, right? That is equal to 1 you get. So what is then?
No, sir, I did it in our question. The question that we had, I did it there, 1 by h. So we'll be left with 1 by h only.
No, we don't, right? I have written fx time fx at 0 0. This is this, right? Fx at 0 0, whatever I calculated, I got the limit as h tends to 0 sine 1 by 8. Is not it?
Yes, sir.
Right?
Yes, sir.
Yeah. So both of you are agree with me, right? Fx at 0 0. This is nothing but limit h tends to 0 sine 1 by h only.
Yes, sir.
Yes, sir.
Then how you show that this does not exist? You told, both of you told like it does not exist, right? Let's discuss why it does not exist. It's a little bit little complicated. I mean, not I'll say complicated. It's very interesting. It's not maybe needed for you. You just if you know sine 1 by h does not exist, then also you will get like you will go through in your course, and I think you are both of you are from engineering background. You no need to mainly do this precisely, but so it is easy. I can teach you. That's why I'm telling you why it does not exist.
Sir, I
I
am
mean,
from pharmaceutical background.
oh, that yeah, but good you are taking up this course. That is also
Yes, sir.
good. I mean, see, knowing something is like might be useful later for any other thing. In pharmaceutical also you need some maths, but not this much. I think this much math you need, right? But
Yes,
yeah,
sir.
might be some days you will be while doing research or something, then you don't have things when many things will be together and you have to do some complicated thing where you need to do this type of things also. It means if you don't know also it will be fine, but if you don't know then you have to ask someone else and then you have to do some collaborative work. But if you know these things, then you will do you're the alone, like you will be the king, right? I mean that type
Yes.
of yeah. So that's why you need if you know something that is very good, and if you are from pharmaceutical background and you are doing maths, I am very proud of you. And yeah, it's very good. Yeah.
Thank you, sir.
Where are you from?
Sir, from Odisha, Raulkela.
Oh, I see. Okay, first, yeah, let's tell me. Yeah, why sine 1 by h does not exist limit h tends to 0? It's a little interesting. See, here also you can use path approach also. I mean, not path approach, I mainly use a sequential approach. See, limit h tends to 0, if it exists, it should be equal to limit h tends to 0. Sorry, I mean the h you can take like, sorry, I'll tell you what to write. I mean, yeah, n tends to infinity. N tends to infinity. So you take h equal to 1 by n pi. That is also converging to 0, right? As n tends to infinity. So, sorry, not n tends to 0 here, n tends to infinity sine of 1 over 1 by n pi, right? If the limit exists, then it will be equal to 1 for n pi. So sine of n pi equal to limit n tends to infinity sine of n pi. What is sine of n pi? N is a natural number,
0.
but that is 0 always. So this will be equal to then 0. But the interesting thing did not come yet. If you take h equal to 1 over n pi plus pi by 2. Let's say not n pi plus pi by 2, let's put it 2n pi plus pi by 2. Okay? That also is going to 0 as n tends to infinity. So if your limit exists, that limit will be equal to place little bit place is not there. So that limit, then limit as h tends to 0 sine 1 by h, if limit exists, that will be equal to limit as n tends to infinity sine of 1 by 2n pi plus pi by 2. Sorry, 1 by 1, so twice 1 by it will be, right? 1 by, because h is 1 by 2n pi plus pi by 2, 2n pi plus pi by 2. So what is this? This is nothing but limit n tends to infinity sine of 2n pi plus pi by 2, that is equal to 1. Sine 2n pi plus pi by 2, what is the value of sine 2n pi plus pi by 2? Sine pi by 2 plus 2n pi implies equal to cos 2n pi, and cos 2n pi is always 1 in all the odd valued pi. For the when it's odd valued multiplication of pi, the cos is 1, so sine 2n pi plus pi by 2 is 1. Do you get the interesting thing here? So you approach with by taking two different sequence here. You get different limit. So that cannot happen. If h tends to 0 limit exists, whatever type of h you take, the limit should exist. And limit should be equal to 1. But limit you see, that limit is different limit you are getting. You take another type of sequence, you might see different limit. So that should not happen if the limit exists. So if the limit exists for any kind of sequence going to 0, I mean, if you put in the very simple word, f has limit as suppose f has limit L as x tends to x naught, then, or if and only if for all xn sequence such that xn converging to x naught will imply f of xn should converge to f of x. I think sorry, f of x naught. I think it might be a little bit difficult for you, but if you don't know also, it's fine, because I am the end of in this lecture, so just giving some extra thing. If you want to take it up, then fine, otherwise leave it also, no problem. But you need to know only that this thing, that sine 1 by x limit does not exist, or cos 1 by x limit does not exist, but reason is this. Is it clear to all of you?
Yes, sir.
Yes, sir.
Oh, okay. It was a little interesting, right? I mean, why it's
Yes, sir.
yeah.
Yes, sir.
Yeah. So for cos 1 by x also we can do like this way, and there are many complicated function. for there also, for them also you can do like this thing. So yeah, so that was I think today's class. Yeah, if you have any doubt, I have some extra page to do some calculation maybe. If you have any doubt, you can tell me. I will do in this extra page. Are you doing the assignments or not? Anyway,
Yes,
whatever.
sir.
Okay. Whatever I am doing here, those are like kind of similar type of questions will be there from assignment also. Means I check the assignment, what type of questions are there. So yeah.
Sir, in NPTEL final examination, sir, it will be MCQ based or will subjective or anything like that?
Okay, that I have no idea. I might ask people, but I never gave NPTEL exams. Although I took the NPTEL courses, but I never appeared for the exam. And I don't have any official communication about those exams. Most probably it will be like the MCQ questions only. But anyway, you see you have to solve like this, like defensively to check all these things. So, if you ask whether it's defensible or not, whether possibility exists or not, whether continuous or not, then you have to do all these calculations. But most probably it will be the MCQ type questions. I think you can search in your the NPTEL in the inside NPTEL course if it is there. But all these things are not communicated officially with us that whether this will be on exams, because exam time will not be exam we will not involve, we will not make questions and all. Most probably will not be, they will be just teaching these tutorial sessions. So that's why I don't know, I have no idea. I check in the internet the NPTEL, or ask someone who gave exam last time.
Thank you, sir.
Yeah.
Excuse me, sir.
Yeah.
Sir, for the previous week, could you please help me write the expression for f of xy and f of yx? Because everywhere I'm looking, I'm getting some different type of expression. And there was one question in the assignment also which I was not able to solve because I did not understand that.
Which one?
Sir, f of xy and f of yx.
Yeah. F of
So
right, f of xy and f of yx.
no, sir. When we differentiate it twice, so f of yx,
Okay, f of
double
y. Understand,
differentiation.
understand. So
Yes,
you
sir.
want, suppose f of, find out f of xy at 0 0.
Yes, sir.
So
What will
what
be
you
the
do, limit. So f of xy at 0 0, you can think like this maybe del x of fy at 0 0. I mean that kind of like, let me clear it. So then h tends to, you start with then h tends to 0, f of y at h0 minus f of y, just instead of f it will be f of y, but the as x is first, so I will take h tends to 0 and this will be 0 0 over h. Some people say that they use different notation, I mean they define in such a way that f of xy, I never seen, but people say that they think this is del y of fx. So that can be some defining way only. But whatever usually I have seen, this is not I have seen. I have seen f of xy is equal to, has to be del x of fy. And you know what is the definition of del x of f at some point, right? That is nothing but this definition with, instead of fy it will be f. And so that's why the f of xy definition limit as 0 0, this will be this. And you now know what is, how to find f of 0 0, fy at h0, all these things you know how to find out, then you find
yes,
that
sir.
this limit, right? Is it now correct? Okay.
Yes, sir. Sir. Also, because we'll get this, and so I'll have somewhere to write. Can you please write for f of yx also?
Exactly, I will be writing, of course, no, what's the problem. So f of yx, so you can anyway, one thing is instead of 0 0 you can put any other point also. Let me write with any other point.